Okay, in light of the 3 video segments that I prepared for the problem chapter 19, I will be doing this problem and I'll approach it exactly the same way. What we have here is, think about it as a table, four-legged table, and in the middle section there is a piece like that hanging, okay? And the first video segment is going to be solving this problem without using any symmetry, using a hybrid analysis where assemblies are strictly used. Okay, so there will be, think about it like that, there will be the solid piece in the middle, block in the middle, there will be a plate in the, which is horizontal, and there will be some legs, 4 of them. The first video segment will not use any planes of symmetry, where in the second one I will be using plane of symmetry here in that particular problem, in that particular video, and therefore here 1/4 of the model, 1/4 of the structure is going to be employed. And again, using hybrid analysis strictly with assembly. And then at the end, in the third video segment, I will repeat the problem where an assembly is not used and everything is done within the same part. Okay. If a problem like that is given to you, it's strictly up to you how you want to do that on the exam, except that you have to meet all the requirements. Okay. So here are the, by the way, here are the dimension in case you want to screen capture and you want to see what was used. But let's go ahead and this was on a earlier on a final exam in some other year. Okay, so immediately I'm going to save this thing, file, save management, save as, desktop, new folder. I'll call it hybrid assembly table, no symmetry. No symmetry is being used. On the exam, you have to use as many planes of symmetry as are applicable. Okay, let's start with making the, for example, the block. Okay, so insert new part in there, and let's call this thing the block. Right-click, properties, block, and block. Say OK. Let's go make it. On that horizontal plane, I will sketch a square which is, according to the drawing size, 2 inch by 2 inch. So I'll center it nicely because eventually I want to cut it with different planes. This is going to be 2. This is going to be 2. So 2 and 2. Exit. And we're going to pad it. Of course, you have to be in part design in order to do the padding by 2 inch up and 2 inch down. So 2 inch up, 2 inch down. Mirror extent, which means this is 4 inches. Okay, good. Then we're going to make that plate, or that horizontal plate. So let's go to the product, save everything. And then we're going to insert new part, call it plate, right-click properties, that's the horizontal plate, or the tabletop if you want, plate. Okay, let's make it. On that horizontal plane, again we sketch. This time we're going to draw a 5 inch by 5 inch square. That's going to make up the plate. Let's dimension it. This is going to be 5, and this is going to be 5. exit. Now I want to make put a surface on that, so I go to wireframe and surface design or generative shape design. The choice is yours. So let me go to mechanical design and wireframe and surface design, which is the baby version of that generative shape design, and use a fill right there. See that? Fill that sketch. So it's going to put a surface. The only thing is that I want to make a hole here. So on that face, I will sketch. Why did I project that entire silhouette? Right there, as you can see. Exit. And now if I hide this, you can see what happened here. So I have the surface and I have this that I'm going to cut it with. So right there, split that surface with that silhouette. Okay, very good. And if you bring this thing in the front so that you can see what happened, this is what you got. Now we're going to make the edges, the legs, 4 legs. Okay, so let's go ahead and now you can, if you want, make the 4 legs at the same time. So that's one option. So but I'm going to make 4 legs, leg 1, leg 2, 3, and 4. So insert a new part. Sorry, insert new part in there. Say no. Now, really, I don't know whether I should. Maybe I should call it, instead of making 4 legs, I'll make a part called leg, and those lines are going to be in it. So let me go that route. Okay. So properties, legs, and legs. There are different ways of doing these problems. So since there's 4 of them, I decided to go that route. So you go to that part, and then we're going to make 4 lines. 4 lines. The method of construction is going to be point and direction. So that the point is, for example, let's start with this one, and direction is Z, and reverse the direction so that it goes down, and the length of the leg is 5 inches. So I put a 5 here. There we are, and repeat this thing 4 times. So again, this time this point, direction Z, in the other direction, 5 inches, repeat it. This point, direction Z, flip the direction, turn it around, line, that point, direction Z, and flip it. So this is what we got. Okay, so let's go ahead and first of all, let's assume that everything is made out of steel. So we're going to make everything out of steel. All the parts are made out of steel. Otherwise, you have to assign the material part by part. All right, and this is fine. So we're going to save everything, and now we're going to go to generative structure analysis. And CATIA immediately meshes the block. Okay. So in fact, if you looked at the size, if you look at the mesh, you see that only block has been meshed. Change the rendering so that you can see the element edges right there. Okay, now to do the other ones, you have to do that manually. So let me deactivate this. So let's do a shell mesh of that surface. Let me make this thing 0.2. Okay. Now let's also put a thickness on it. I don't know what the thickness in the problem statement is. It says 0.1. So read the drawing carefully, the graphs carefully. See, it says 0.1 on the top left corner. It says 0.1. All right, and we say okay. So let's look at the mesh. Now you're going to see the solid and the shell. Okay, deactivate it. And now we're going to mesh these other ones with beam elements one by one. So we go to the beam mesher. I don't think you can do that multiple times. You have to do that separately. You cannot select it in a multiple way. Now it could be that if you pre-select, you can do that. Let me try this. So this, control that, control this. It is unlikely, but we're going to see. Mesh it with beam. No, it looks like you have to do that one by one. Okay, fine. So let's start with this. That's okay. I did this one, and then again, that one, it's okay. This one is okay. And finally, this one at the end. Now, if I say, by the way, the problem says that these legs are circular with a radius 0.05 inch. So why don't we do that right now? So click on this, 1D property, make it circular, cylindrical, a radius of 0.05 inch. Okay, and then say okay. Now with a circular and tubular one, you don't have to select the orientation point. So if I select this, notice that it did put a circle there, right there, and the radius was 0.05. And you have to do this thing 4 times. So once again, same information. What I don't like is that we have, how come we can't see this? I was unable to see that. These are not showing on the screen, so I like to know what's going on. Let me actually see. It's there right here, but I cannot see the cross section. Well, all right. Let's actually display the mesh, see what happens, and then we go with the other two. Yeah, right there. So that's fine. So we have to do the other two. Deactivate this. Okay, so one more time. This one. And one more time. That one. Okay, so the meshing is done. Now let me hide these sketches. This sketch, I'm going to hide it. And there is a sketch here because I've projected, I'm going to hide. Okay, now we're going to create our connections. Okay, well, what do we do first of all? What do we do the clamping here? We are told that the bottom of these things are clamped. We can do that at the same time or one by one. That's entirely up to you. We are not using symmetry, so a total load of downward direction of, if you look at the problem statement, it says 500 pound. There is the problem statement, 500 pound downward. So we put another 0. There is my force up there. And now we create a connection. We are assuming that this plate, or this block is fastened to the surface. Okay, now remember in the previous problem, what I did, there was a circle, so I selected the circle and it was just, you know, a single curve. But here there's 4 of them. Let's see if actually we can create to make our job easier. So let's see now. This face, for the second component, I can select that edge. Zoom in, that edge. So I can go the same route doing 4 of these. The alternative, there is an alternative. Actually, let me cancel that. Try it again. This one, and hide that. For the second component, this edge, okay? And these are the 4 edges. The first four are going to be fastened. So I have to do this thing 4 times. There is another way of doing it, and let me cancel this, although this is possible, but there is another way of doing it, and that is create a connection between this face, I guess, and that face, okay? Instead of saying this edge, I can select that face, okay? You know what? I will do it exactly like it was done before. Okay, so I'm going to hide this. But instead of selecting this edge here, that's what I'm saying, we could have selected the face. It would have done the same job, okay? So again, another connection between, the order is not important, so I select the face that I can see right now, and for the second component, I select this face. I don't have to bring it into show mode, so right now there will be 2 of the connections made, and another one, once again, between this edge, and for the second component, let's go to the hide mode and turn this thing around and select that face. Okay, and finally another connection between this last edge, and go to the hide mode and select the side in the back. Okay, let's bring this in the front. Okay, these are all going to be fastened. While we're at it, we might as well do that right now. The fasten connection is in the face-to-face connection property. So there's the fasten, see that? And we can select them from the tree, these 4 from the tree. We have to do it one at a time, but why don't we do that? So this one, do it again. The next one, do it again. The third, and the fourth. If you look carefully, you see there are 4 fasteners that are left there. We then have to create a connection between vertex of this line and the vertex of that sheet, and that has to be done as a rigid connection. Okay, so connection. You have to be careful here because the duplicate nodes sitting on top of each other. So let me hide this for you. Select this vertex. Okay, and for the second component, let me bring this in the front. Let me hide this and hide the connection, and now select this point. And this process has to be repeated 4 times, and these are all going to be rigid connections. So another one, hide this. First component is here. Second component, bring this in the front. Hide this guy. Hide the connection. Select that point. Repeat it again over here. So connection, hide this, select that point, second component, bring this in the front, oh, I wanted to select the, actually, I wanted to select the, I wanted to hide this connection, but accidentally, let me see, yeah, that point, and the last one, another connection, hide this, hide the surface, select that point, second component, bring that into the show mode, hide the line, and hide the connection that is preventing me from picking it. So that point. So we have these 4 connections. These are all rigid. Now rigid is in the distance analysis, distance connection property. Unfortunately, fasten does not work for vertex to vertex. Okay, so rigid, this, rigid, the second connection. Second means number 6, but that's what I mean. Rigid, connection 7, and rigid connection ends. Okay, if you want, you can bring these things in the front. Really, it doesn't matter, but some people may feel more comfortable if everything is in front of them. There we are. Why don't we save the analysis file? File, save management, analysis, save as. Okay, hybrid assembly, table, no symmetry used. Okay, so it's going to go in that right folder. Very good. I think we're all set. Everything is set, so let's go ahead and run it. There we are. So let us look at the deformation, and we can animate it. There we are. You can look at the amount of deformation, or the amount of displacement. That's what I meant. Average ISO, material shading. There we are. The drawing of the displacement of the beam is not right in my computer. Yours is going to be okay. And finally, the stress distribution, which is right here. There is no stress, one meter stress that can be drawn in the beam elements. Okay, it's easy to generate good-looking garbage. You should then, if you're getting paid to do these things, you should look at the numbers. Does it yield? Does it not yield? Etc. So what I'm going to do is I'm going to save this entire thing in a separate folder because I want to start in the second video segment. I'm going to start cutting this. Okay. So file, save management, the product, save as, desktop, a new folder, and my new folder is going to be hybrid, assembly, table, cable, two planes of symmetry use. There are two planes of symmetry. Two planes of symmetry. Okay. And make sure you say propagate directory because you want the parts also to be there. We don't want the analysis to be there, but the parts are. Let's go and check. I'm going to close all of these. So I created a folder here with that name. Let's see now. Hybrid assembly, table, no symmetry. Where's the other one? Hybrid assembly with two planes of symmetry. The product and the three parts. The three parts, the legs are all in the same part, right there. Okay, so let's start the product, and I'm going to stop the video segment here, and we start this. We do